Hello everyone, I'll take you through the next update, which is configuring different administrative distances for OSPF processes in a VRF. So let's dive into the feature. So before we get to the feature details, let's talk about administrative distance, which is an important concept in routing protocols. So admin distance is essentially a value assigned to each routing protocol that indicates its preference when choosing routes. So what is the purpose? So the main purpose of AD values is to act as a tiebreaker when the same route is learned from multiple routing protocols. So each routing protocol has a predefined default AD value. So here are a few examples for directly connected routes, for static routes, along with their AD values, followed by OSPF, eBGP, and iBGP. So let's talk about the route selection process before we jump into the OSPF stuff. So the route selection happens in 4 main stages. So route selection within each protocol, that is within each routing protocol. For example, protocols like BGP might have many routes for same prefix, and it will elect one of the best for the BGP. And then this gets compared with other protocols. So the next step is the candidate routes. And when it learns the same route from different protocols, it must choose the best one. So how is this done? So that is when AD value comparison comes into picture. So the router compares the AD values of the routes, and lower administrative distance value indicates a more preferred route. And finally, the best route with the lowest AD value is chosen and added to the routing table. So now that we spoke about admin distance and route selection, how does this OSPF based feature relate to all that? So in the current setup for OSPF, it uses a single uniform admin distance value for all the OSPF processes in a VRF. We can have a maximum of 8 processes per VRF. So all these VRFs will have the same AD value, which is the current limitation. So now imagine you have 2 OSPF processes. The system automatically applies the most recently configured AD value to both, even though the user wants to have different AD values for each of these OSPF processes. So as a result, this creates a conflict and overrides the flexibility to differentiate between the process, limiting how routes are selected and prioritized. So this limitation can reduce routing flexibility, and one major problem that it can cause is fine-grained control over the routing table. So this was the key challenge in the earlier versions, and from 10.15, this has been addressed, and it is very crucial for improving the routing precision and scalability in dynamic environments. And we must also note that this is specific to topologies using multiple OSPF processes in a VRF, so it may not affect simpler setups. So with the latest enhancement from 10.15, users have the flexibility to assign distinct AD values for each OSPF processes in a VRF. So this means that adjustments made to the AD of one OSPF process will not affect or impact the AD settings of the other process within the same VRF. So to your left, I have 2 examples, that is one before 10.15 and after 10.15. So before 10.15, whenever we get into the router OSPF context, so here I have router OSPF 1 and applying the distance of 150. And in router OSPF 2, I'm applying the distance of 200. So irrespective of me assigning 150 to the OSPF 1 process, 200 still gets applied to both of these. So this was the limitation. And we could also see this limitation here. Distance 200 will be applied to all the OSPF process within the default VRF. So that was the issue. So now from 10.15, this has been eliminated, and these values are not being overridden. So now if I assign two different AD values to the router OSPF1 and then router OSPF2, you can see that they're being taken as such without being overridden. So the main benefits of this feature are that user can now prioritize the routes learned from one OSPF processes over another. And it also allows for better control over which routes are preferred when multiple paths to the same destination exist. And here you can also see the supported platforms listed. So let's talk about the use cases. So this is very much useful in multi-process OSPF setup in a shared VRF. So it helps to enable precise control of route preferences by prioritizing specific OSPF processes for routing. So the next is enhanced route control and preference. It allows preference of specific OSPF routes without unifying all the process under a single AD. For example, you can assign a lower administrative distance to primary routes and higher ones to backup routes of a failover paths. So the next is improved routing for diverse network scenarios, which includes both campus and DC environments or MPLS or WAN backbones. So in the campus and DC environments, you can tailor the AD preferences, let's say for core versus leaf devices. And in MPLS or WAN backbones, support is offered for diverse upstream connections or regions with independent AD configurations. And finally is the simplified network expansion. So adding new OSPF processes does not affect the AD of the existing ones, preserving the existing routing configurations as well. And this prevents any disruptions and avoids reconfiguration during network growth. So these use cases illustrate how distinct AD configurations enhance the routing flexibility and scalability and provide more control. So with that, we come to the end of this session.